Hello, welcome back. Today I'm doing construct binary tree from pre-order and in-order traversal. Yesterday I did yesterday I tried constructing binary tree from pre-order and post-order. So in this one we have pre-order instead of post-order. Same version, just given the array pre-order and post-order. You just have to construct a tree. Let's see how we'll do that. Pre-order pre-order can tell us about okay, root. In order 9 3. Okay, so the first element of pre-order is going to be our root, and we have to find the same node in the in order, and then we will look its left side, and then we will look on its right side, and then we'll run the recursion on these elements. Okay, I mean this one is easy, I know. Then this one is easier than the last yesterday's problem. Okay. Yeah. Private tree node construct tree. It will accept, of course, pre-order and post-order, pre-order and in order, and besides, what else is it going to need? A start and end. Start and an end. And well, the start and end is really for, it's what we're going to use in our, it's used in our in order array. And we will use one more index, pre-index, which will tell us about the root. So here I'm just gonna return my function. Give me a constructor tree. Pre-order, in order, start is going to be 0, and is going to be size of any array, length. Lastly, pre-index, it's going to be 0, because we'll start building tree from the 0th index. So first of all, I'm gonna say, give me a root, new tree node, at index pre no pre-index pre-order index pre-index and increment immediately. Increment pre-index immediately. And at the end I will return this root. So whatever has to happen will happen between these two lines. Since it's a recursion function, because it's we need a base case. Well, I'll say when it's gonna be like binary search. So we have, well, we can use 3 for here. So basically it's 3 and then we will locate this 3 inside inorder array. Okay. And this 3 is present at first index. Let's locate 3 now. So we're just gonna run a loop. In order length I plus plus if in order I is equal to roots value, then let me just set some variable. Let's say some k is equal to I, and then we break. Come out of this loop. Now we know now we know about its current roots left child. So I will say root dot left is construct tree, take both these arrays pre-order in order and start constructing it from, we're building zeros, right? So zero, we are building left side, so from 0 till k minus 1, because k is the root, k minus 1. Yeah, starting from 0 till k minus 1, and our lastly pre-index. It's gonna stay the same. We already incremented it here, so I don't think we need to. I think it's fine if we do it just this way. Root dot right for the right side. Well, we start from k plus 1 and till end, and pre-index. Okay, now base condition. Pre-order and in-order does not tell us about no, both don't tell us about. Yeah, both don't tell us about nulls, where the nulls are going to be in the tree. Let's say if start is greater than end, return null. Or pre-index is greater than pre-order dot length minus 1. Return null. This should work. For some reason we are having duplicates. In order. Why are we having duplicates? System.out.print roots value. Three, nine again. Why? Because of the okay, because of left and right thing. Okay. How do we avoid this situation? I need a visited array. 9. Or well, this 3, this 9 is by the left, by left call. This 9 is by right call is 20 is probably by left, then left, and then left, and then again, then this 15 is from right, and then right. Okay. We need to check if it already exists, if the root, if the node's been already built. But we need hash map for that. Hash map hash map dot integer node map new hash map for for in order. Let's say map dot put are null. If map dot get pre-order pre-index is not equal to null, then we return null. But we can't return null actually. Let's see. No. No. Now we have external. The same before. It was same before. 399 null. Without this, it would be. Yeah, it's the same. Nothing changed. Why? Pre-order index. Well, this passing pre-order index is pretty tricky because both calls have access to the. What if we don't? in order, in order. K, we're checking K to the next, and then we're breaking out of in order, in order, in order. Well, I don't know how to. I don't know how to do this correctly. I have pre-index. Uh, and obviously, this will not work. Uh, 0. Starting pre-index from 0. Start is greater than end. Well, let's just say we, yes, expected that, expected that. Oh, uh, if pre-index is smaller than, it's smaller than pre. Okay, what if pre-index is smaller than the bound? Do everything as you're doing already. If it's greater than, if it's greater than, then we want to come out of which, can I have a hint? Uh, if pre is it becomes greater than. This is actually right step. 3920, 3920, 3920, null null, 157, null null. We're starting from here. We're starting at the root. At this level, the index is a 1, 0, 0th index. And we find this. So left call from 0 till 0 till 0 1. 0 1. Well, no, this will not work. Don't need to pass in k-1 first, then this condition would hit. Okay. K plus 1. From 0 till it's taking so much long. 3 3 3 3. Increment this. In order, pre-order, in order. Well, no. Once we are in this call, the start is 0. Oh, the start is 0, the end is 1. And is 1. This condition is already 1. Well, I can see why this is not working, but okay. Well, we know that a root element is at first index in order node. Start. Okay. Period 0 till k. This is where the problem is. Start is not greater than end. Then we are creating a node root. We are checking pre-order array. So pre-order array next node in the pre-order array is 9. So we've created 9. Now we are trying to locate the 9 in order. We found we, we found 9 at 0th index. So k is 0. We're passing in 0 till 0. Obviously that would not run, and 9 will have a null as a result, but that's not happening. 9 is not having a null as a result. There are so many elements. Let me see. What's the start and end? Start and end. Start and 1, 2, 3, 4. 0 to 1. 0 to 0. It should return null. Well, if it's 0 to 0, how did it get here? Well, if it's bigger or equal to. Oh, at least we have a lot less elements now. Okay. 0 to 5, then 0 to 1. Yes. 0 to 0 never got till here. The return, it was already returned. Then 2 and 5, that's for the right side, and index 0, 1, 2, and 2 to 0, 1, 2, 5. Yes. Let's check the value of pre at each call. Pre-index. Zero. See, this is where the duplication is happening. Plus 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 plus. No. Uh-huh. What? 0 to 5, 1. 0 to 1, 2, 2 to 5, 2 to 5. This is for left call, this is right call, both having same pre-index. Pre-index. Okay. Let's look at some hints. Java, defer search, plus plus, plus plus, divide and conquer. Yes, divide and conquer. Pre-start dot get roots value. Pre-order, pre-start plus 1, pre-start plus left size plus 1. Is there a formula for this? I found this code on the YouTube, and this guy is also not. Uh, this guy is also passing the pre-index as VR. So, oops. So let's case in order. Build tree. Okay, he's building tree after the pre-index is incremented. Uh, okay, so that means that we'll check for pre-order pre-index. Bound, how to bound pre-index. K minus 1. Okay. Okay. I minus 1, start, end. This is the most easy to read solution I've found. We are making use of a hash map, and I just remembered that when I use hash map, I forgot to put the updated value of the root. I was only checking for get, so that was really stupid of me. Here, well, this condition is the same. We are not creating root as soon as we enter the function. We are only getting the value of the root, and then I think we are checking if that thing exists in the hash map, and then we are creating a new root. Then we are incrementing our pre-order index, isn't it? And we are calling construct function. So left, and there is no loop here. In order put in order I in order I that I. So yeah, we are storing the indexes and the in order nodes in the map. Then root. Oh, let's bring it here first. Yes. So keeping track of uh, in order in order. So basically, this map take cares of finding the index from the in order array, and so yeah, we don't need loop here, but that still doesn't explain why my solution was not working apart from that. So global, and also this code does not use the condition. It doesn't check bound check. Only the left is greater than right. In order index, index. Then we are checking left, and in order index minus 1, in order x minus right, length minus 1. pre-order index. Let's go back to my code now. We don't need to pass this. Let's pass this. Okay, start root value. Grab the value of okay. Mm, 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 mm. Okay, keeping the pre-order index as in global scope. That way, it won't be duplicated. I think I got it. So pre-int pre-index 0, pre-index, move this from here, pre-index, pre-index. We're checking this pre-order in pre-index, finding key. Good. Construct tree cannot be applied. Okay. Okay. Please run. Oh. Is it still? Yep. Let's just look at the solution one last time. Maybe I really need to use hash map. I'm just trying to avoid hash map. Pre-index in order. Pre-index starts 0. Pre-order index in order index. And left till -1 in order. Pre-order map in order. fruits value. Fruits value. In order. Okay, I need to. Okay, I need to understand the solution properly. Okay, this is just me trying to shoot in the dark. Yeah, this was a hard question. Next question. Merge intervals. Given an array of intervals where interval start and end, merge all overlapping intervals and return an array of non-overlapping intervals that cover all the intervals in the insert interval. This one is merge interval. 1, 3, 2, 6, 8, 10. So 1, 3, 2, 6. There is overlap here, and this whole thing becomes 1, 6. Now comparing it with the next interval, 8, 10. Okay, there is no overlap. Yeah, there is no overlap. What? No Python, no Java. Print. What? Yep. Intervals. Okay. Just took a 5-minute walk. The last version was still in my head. Okay. Well, we are going to need a list first of all, because we don't know how many intervals there will be in the result. List of intervals. Result. New array list. Return this list. Let's say current intervals at 0th index. We are starting iteration from first index. I is smaller than intervals dot length I plus plus Oh, well, let's say selected interval and current interval. Intervals. Current is the interval of the index. Interval of this in this loop. This is our selected one, and now we need to compare if, just checking from if selected's ending is greater than or equal to current index starting, then we need to merge them. Okay, so selected 0 is going to be math dot minimum between the startings of both current intervals start and selected start. We'll do the same thing with their endings. Max at index 1. So this thing this thing now will become something like this. Yeah, something like this, and we need to add this to we need to add this to a list, main list. Or should we wait, because we still don't know if this gets merged ahead. Selected this too. Okay, so in next iteration we will compare 1 and 6 with 8 and 10, and it will go into else case. Else we simply, well, when there is no conflict, when there is no overlapping, we just want to add the result, what is the result here? current interval and update the selected interval with current interval. Okay, so now 810 becomes selected, and we are comparing it against this. There is no conflict. This goes into the list. And then finally we are returning a list at the end. Uh, Result dot add selected. Though I'm not really sure about this stuff. Okay. To array new int result dot size. I believe this is how you turn a list to an array, to the array. Let's check. I don't find this. You gotta add the type. Okay. We also need to sort the list. Output. If no loop never runs, selected piece never goes into input. So what if outside the loop, but then it first case is not. I got it. Well, if we can say if the value of if the size of the list is 1, well, if intervals dot length is smaller than 2, just return false. Lot of edge case. This is not an edge case. Same case. We keep 1 1 4 as we're starting from this index, and there is no. So instead of doing this thing here, oh no. No. If there is no overlap, selected should go to the result, right? Current interval. So the first two elements become 1 6, and 1 6, comparing it with the 8 10, there is no overlap, so we are adding 1 6 to the list, to the result. Then we are updating selected value. Now it's 8 10. Okay. If we keep doing this, now 1 6 is in the final list, comparing with 8 10, selected is correct. 8 10 selected is 8 10 now, and no conflict with current interval, so selected will go to the array, in the list, and value of select, it's getting updated with. So at the end, but at this point loop will break and we'll get out of here with last element still being left, out of, still being not present in the result list. So I can say cell.add selected okay. This array is not sorted. We need to sort the array. How do we sort this array? Compare. How do you sort arrays? How do you sort custom types in Java? Compare dot. What library was that? Collections dot compare. I'm not sure. Making sure it exists. I don't find the symbol. Something like A and B is checking. A minus 0, B 0. Intervals. Comparator compare. I am forgetting. Submission. Arrays dot sort. Arrays dot sort. Okay. Cool. What is the space and time complexity? Space complexity is O of n. We are maintaining a array, or this result array, and time complexity is sorting takes log n, and this is happening in a time n and log n. And log n. Okay. Good. So today's score is 1/2. In the I still feel binary search. I'm still thinking about the tree question. Uh, okay, bye 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 bye.